Hello everyone, and thank you for joining us for this webinar. We are excited to bring you this overview webinar on ETAP 20.6, a continuous intelligence digital twin solution to plan, design, automate, operate, and optimize electrical power systems. ETAP 20.6 offers an impressive set of enhanced integrated power analysis modules, new safety capabilities, and digital transformation solutions. We have included hundreds of enhancements and time-saving improvements into 20.6, but given our limited time, we'll focus on some key improvements. So let's go ahead and get started. ETAP Digital Twin is a unified engineering and real-time platform used to model, design, visualize, analyze, predict, control, and provide insight on management and performance of electrical power systems. The ETAP Digital Twin goes beyond an integrated engineering analysis tool and provides you an active blueprint of the electrical system that is able to give you rule-based design, model-driven predictive analysis, a CoSimulation platform, an operator training simulation hub, and it combines with real-time analytics, asset performance monitoring, intelligent controls, and more. By connecting ETAP Digital Twin platform to a larger ecosystem of complementary and collaborative solutions, we are enabling a transformative role for our customers to design, operate, and connect on a multidisciplinary scale. Harnessing the power of ETAP and its ecosystem throughout the digital transformation process helps engineers, operators, and managers increase their awareness and understanding of their power systems, and in a cost-effective and repeatable environment. We continue to improve this transformative journey through ETAP 20.6, where our technologies and best practices are used to design and operate power systems safely, reliably, efficiently, and maintain compliance. We've added new capabilities to ETAP 20.6, allowing you to ensure safety and maintain compliance. These include a public safety magnetic field exposure evaluation based on underground cables. You can reduce risk, improve safety, and enforce compliance based on new DC arc flash calculator based on German standard. And you can automate your sequence of operation studies for STAR and STAR-Z based on the ETAP study wizards. ETAP 20.6 has also been enhanced, giving you more flexibility for your design and analysis, with massive improvements to the AutoCAD DWG import and export capability, which we call XCAD. New plot analyzers for existing ETAP modules have also been added that allow you to perform graphical plot comparison. The ETAP API now allows for even better interoperability using the RESTful API. ETAP 20.6 continues its enhancements for renewable energy integration and grid compliance. At the forefront is ETAP GridCode, which now allows for ENA, EAR, G55 based Harmonic grid code compliance. Transformer Inrush allows for not only transformer inrush simulation, but is also capable of providing deliverables that are intended for grid code compliance. Solar PV estimation allows us to model any type of solar panel directly in ETAP, and we continue to improve and add new solar panels directly into the ETAP library. High-Fidelity simulation allows for better design flexibility. Plot view allows for flexible charting and live plotting now in many different ETAP modules. Scripting and automation through etapPy has been expanded, allowing you to get, set, and even create or delete elements. Electromagnetic transients, or EMT CoSim, is now automated through the study wizards, allowing you to perform more simulations at a click of a button. Intelligent schematic builders and views have been expanded by integrating the UGS system with the cable magnetic field calculations. The one-line diagram has new capabilities for visualization and representation of the graphical results and information. The ETAP interface, of course, has multiple enhancements throughout the program. We have also enhanced the design speed and accuracy by improving NetPM, allowing you to synchronize project settings and composite network information. Data exchange now has new conversion methods as well as improvements to legacy conversion tools. A new version of ETAP app now brings search and auto backup capability with an upcoming Android version. We have also enhanced our model-driven design and control solution, which is based on software and hardware. That includes the ETAP microgrid controller and energy management system, as well as the EPPC or power plant controller. Unified Power System Situational Intelligence is now further augmented by expansion to the eProtect relay adapters and improvements to the type of data that we exchange between ETAP and other assets. Operator Training Simulator has better interfaces and better visualization of the training simulation results. And we've expanded our visualization as well as the prediction of fault analysis and the fault location system. So let's go ahead and get started with our very first capability, which is magnetic field intensity evaluation, which allows for better safety and compliance. The purpose of the underground cable magnetic field calculator is to determine if the field intensity exceeds the acceptable limits for long-term or short-term exposure. The health and safety aspects of the analysis are a comparison of the calculated field intensity against the selected magnetic field exposure limits for a worker, the public, or any individual with a medical condition that is sensitive to electromagnetic field radiation. The magnetic field exposure module is integrated into the underground raceway system. By calculating the current flowing through every single conductor or entering that value, the program can determine what is the magnetic field strength around these cables. The magnetic field strength can then be compared against limits, such as public limits, individuals with medical conditions, or workers who are working nearby these conductors to ensure their safety and to maintain compliance. The magnetic field information can then also be plotted and displayed into the magnetic field evaluation tool. So let's go ahead and take a look at this module and see it in action. From our underground raceway system program, we can bring up the magnetic field calculator and essentially look at the magnetic field strength that's being calculated for all the conductors in this raceway. The calculation, as I mentioned earlier, is based on ampacity as well as the current angle, which makes a tremendous difference between the magnetic field strength at normal balance condition versus unbalanced condition. So therefore, it's very important to get these current values as well as the angles correctly and preferably directly from the one-line diagram. And that's exactly what you can do in ETAP. So you can simply go to the one-line diagram, run unbalanced load flow calculation, where you can see your average values or the phase values along with the current angles, which can be visualized directly onto the one-line diagram. You can then take this information, update it into the underground raceway program, and make it available for both the thermal calculation as well as the magnetic field calculation. The thermal calculation quickly gives you the current versus temperature, while the magnetic field calculation provides you with the magnetic field intensity strength for that particular raceway. You can simply look at the results from load flow and use it to compute your magnetic field strength, or you can have the ability to manually change it as well. You can plot a single magnetic field strength at a certain depth. You can also ask the program to give you individual plots at different depths by simply selecting the depth level and adding it to your chart. Or you can simply ask the program to give you the complete range, in which case you can use a fixed step and see the complete intensity at different depths throughout the underground raceway system. You can then compare the magnetic field strength versus the safety limits. By simply selecting the safety limit that you want to comply against and the compliance standards, you can then go ahead and plot these values directly onto the chart. So you can get a very simple and clear safety line and the actual magnetic field strength associated with that particular raceway. As expected, if the intensity of the magnetic field is to be recomputed, we re-enter the ampacity or we recompute based on different scenarios. And we can see based on the change in the ampacity of the current going through the conductor, we can see the change in the field strength directly onto the diagram. You can also use the underground cable magnetic field calculator to manually select the underground raceway system results. You can also export the results to an external database or send it to the plot analyzer. And you can also consider sheath and armor current, ignore ferromagnetic conduits, or even change the relative permeability of air. The tool therefore allows you to evaluate 3 magnetic field exposure limits, which are worker, general public, and individuals with medical condition. The biggest value of this tool is to determine if personnel sensitive to the potentially harmful effects of the magnetic field exposure, such as individuals with pacemakers, are not being exposed to long-term magnetic fields above the recommended limits. The added value of this module is not only that it's used for industrial installations, but you can also use it for commercial and public underground cable installations to make sure that the general public exposure to magnetic fields is below the levels established for the general public. Arc flash analysis is not only a North American requirement, it is a global analysis requirement. In several EU countries, the analysis is performed using DGUV standards. ETAP 20.6 provides you with the capability to determine the arc energy for DC electrical installations based on 2 methods. The first one is called the general or the iterative method, which is very similar to the NFPA 70E rigorous calculation method, or otherwise known in ETAP as the Stokes and Openlander method, but with some variations in the gradients and anode and cathode voltage coefficients. The second method is called the worst case method and is very similar to NFPA 70E maximum power method, but with some variations as well. All being said, this new calculator allows the user to select the PPE level according to VDE 0682-306 energy levels based on the arc energy found from the DGUV equations. You can choose between your input parameters, your method, the fault types, the equipment type, along with the typical data, and essentially visualize the effect of having different working distances and the arc energy and its computation. Just like with other arc flash analysis tools, the German DC arc flash analysis tool allows you to evaluate thousands of locations by means of importing the batch results from MS Excel and CSV files. DGUV standards do not place an emphasis on labeling as much as NEC and NFPA 70E do, but the tool allows the user to also generate and print labels in Dutch and German languages, which include shock risk approach boundaries based on IEC standards. This new tool pairs up with the existing and enhanced AC German arc flash calculation tool to provide a means to calculate the arc energy based on German DGUV standards. The current transformer saturation analysis is an electromagnetic simulation which has been enhanced in ETAP 20.6. In this version, the symmetrical current and X over R from the fault current can be updated automatically into the CT saturation tool to determine the saturation effects and actually visualize the saturation waveform. So let's go ahead and see this in action. You can simply switch over to the ETAP short circuit analysis tool, run the short circuit calculation, and then open up any particular CT that you wish to look at the saturation or look at the sizing adequacy based on the class or designation of the CT. For this particular CT, we can easily visualize the CT rating as well as the CT saturation effect based on a user-defined fault current. You can simply change the user-defined fault current and go back to the saturation curve to see the effect of the saturation in terms of ideal and actual instantaneous as well as RMS currents. But the power of 20.6 allows you to use the calculated value directly from the short circuit program and now visualize the true saturation seen by the CT based on the fault current. Along with the short circuit current update capability, the calculator also has new typical parameters based on the number of secondary winding turns. The calculator also has enhanced initial knee point voltage calculation based on the CT class and burden rating, you can simply change the CT burden and come back to the saturation chart to visualize the new saturation effect along with the sizing computations that are updated based on the new burden class. The ETAP plot view is an advanced framework for charting and graphing. It has been enhanced in two manners. First is plot view for synchronous generator, where we've improved the capability curve and the fuel cost profile. You can simply access the capability curve by opening up the synchronous generator editor and viewing the new plot view for the generator capability that allows you to zoom in, zoom out, and actually even visualize certain data points directly inside the editor. The other page that has improvements is a fuel cost curve, where you can essentially pick between your fuel cost profile and let the program compute the cost versus dollar per hour, incremental cost, and of course the power output associated with the generator. The plot view has also been enhanced for transient stability, where the program allows you to not only plot the transformer inrush curve, but also allows you to plot the transformer inrush RMS curve at the same time. Simply go inside the study case, set the time frame that you would like to run the simulation for, and go ahead and perform the actual study directly from ETAP. You can use any of the scenarios or obviously run the calculation directly inside the program and see the visualization through a live chart that includes the inrush and the RMS current directly onto the diagram. ETAP Plot Analyzer is an advanced graphical plot comparison tool that was introduced in ETAP 20 that is available in all ETAP analysis modules. We have expanded the capability of Plot Analyzer, allowing it to perform even more unique computations, especially for balanced load flow as well as unbalanced load flow. So let's go ahead and take a look at these two examples into ETAP 20.6. You can simply load up your favorite example file, run the load flow calculation, visualize the results, and now you have access to the plot analyzer directly in the load flow program. The program automatically selects the swing bus, and then you can choose between different plot types for visualizing the results in the plot analyzer. Let's go ahead and plot voltage versus distance. What we see is a voltage versus distance plot that gives us our voltage in percentage and the distance in feet. And by hovering on any of these points, you can easily visualize the voltage, the bus ID, as well as the distance from the swing source. And as traditional plot analyzer, you can always switch between dark and light modes and interact with the diagram using the controls on the top right corner. We can go ahead and plot other types of plot analyzer results for the load flow program and go ahead and visualize them all together. We can see voltage versus distance, loading versus distance, power factor versus distance, and so on and so forth, including our branch loss reports, branch voltage drop plots, loading plots, and so on and so forth. We can now go ahead and select our starting bus again and select all the plots in this case and combine them all together. What we therefore see is a combined distance plot, power factor, voltage, and loading versus distance, a branch power factor plot, branch losses, branch voltage drops, and so on and so forth. So the plot analyzer not only allows you to combine different types of plots together, but it also allows you to combine different plot results from different studies at the same time. With the plot analyzer, you can also go into unbalanced load flow module, run your unbalanced load flow program, and then bring up the plot analyzer from within this mode. You can then select between a single or multiple buses at the same time and plot the voltage and current phasors. And the program essentially gives you a beautiful tiled view of all your voltage phasors as well as all the current phasors at the same time. And then once again allowing you to interact directly with the diagram and visualize more information. The other capability in ETAP that we have enhanced in 20.6 is XCAD. It allows data exchange between ETAP and AutoCAD DWG files. By exchanging data between AutoCAD drawings and ETAP, you can streamline work, enhance productivity by essentially reusing the data and not having to manually type the same information in all over again in a manual fashion. You can synchronize engineering, construction, and maintenance teams automatically generate a single line diagram in ETAP and also generate substation ground grids automatically as well. You can simply import the diagram into ETAP in ETAP 20.6, but you now also have the ability to go the other way from ETAP directly into AutoCAD as well and produce deliverables in a native DWG format. The element modeling has also been enhanced in ETAP with, of course, the generator plot views for capability curve and fuel cost profiles, but we also have added the ability for cable operating voltage, current, and angle to be displayed directly inside the cable editor. The motor circuit protector calculated trip currents are also visualized directly inside the element editors. The other application that has been enhanced is ETAP API. ETAP API is a RESTful API for interoperability between ETAP and other programs. ETAP API uses web services-based architecture for ETAP to interact with other applications through data messaging instead of flat file exchange. You can connect to ETAP from any device, exchange data over a REST API. It is also implemented as a Python client in etapPy. And using the API, you can run scenarios, studies, and get project data. etapPy, which leverages the ETAP API, allows the integration between ETAP and Python scripting. You can run the built-in Python IDE for running scripts. You can execute the scripts locally or over remote computers. And the expanded API for ETAP application includes the project data, scenario wizard, and is used for driving studies. You can now use the API to simply clear the message log using the Swagger page that allows you to try out every single command before you actually implement inside a Python script. You can also use the API to get the active scenario from the network. So in this case, we can see what our active scenario looks like. You can get access to all the users for that particular project and essentially see who are the actual users within the tool. You can also even get the current zoom level and figure out at what zoom level are you actually applying this diagram to. You can even use it to hide the ETAP application itself or bring up the ETAP application all over again. The ETAP API has been expanded through Python scripting to now also have more access to the project data. You can essentially get ETAP element information by simply typing in the ETAP element info, and the program essentially returns all the information related to that particular element. You can also use the API to get information about a particular element. If you want to get information about our two-winding transformer, T2, and we want to have access to this particular field, which is the positive sequence impedance of the transformer, we can simply ask the program to query and it returns a value of 2.28, which we can essentially compare and see within the actual application. You can also use the same tool to set the value of the property for this element. We set the value for the ANSI positive sequence impedance, and the value we would like to set to is 7.5. And we can go ahead and apply it, and then go ahead and open up the program to make sure that it actually has been applied. And once that has been applied, you can go ahead and rerun the calculation, and you will see essentially different results. So this way you can use the program to get the data, set the data, and actually run automated calculations. The other power of the program is its ability to also now create elements based on your command. You can use the create element method to create the element of your choice. I would like to go ahead and create a three-winding transformer called T10 inside a composite network sub 2AN. It will be flat, which means it will be available on the main diagram, and it will be created on location 30 by 50. And we can go ahead and actually apply it and zoom out to see our new transformer inside sub 2AN that has been created for us with the ID T10. So with this expansion in ETAP 20.6 in the ETAP API and the Python scripting capabilities, you can not only look at the information about the project itself, the application, but you can also manipulate project data, manipulate the scenario wizard, and of course perform various studies such as load flow, short circuit, motor starting, star sequence of operation, time domain, transient stability, voltage stability, and so on, giving you maximum control over ETAP and automation that you would like to implement. ETAP EMT CoSim is now on version 2.1. It allows for co-simulation of electromagnetics and phasors. This hybrid simulation exists between ETAP transient stability and PSCAD application, as well as ETAP EMT. Accurate and detailed EMT model utilization can be done within any ETAP network model. And the power electronics simulation includes faults, protection write-through, and many more for any shunt-connected device. You can watch your transient simulation in action with the live charts, co-simulate elements per bus and multiple co-simulation buses, allow or apply graphical boundary data charting using rich Python-based plots, and then of course we now allow study automation in ETAP 20.6 using ETAP study wizards. ETAP transient stability also includes accurate power system dynamics and transients based on vendor-specific dynamic models that have proprietary code. The ETAP transient stability API has been expanded to take the vendor-specific dynamic models that have this proprietary code and black box them such that they can be interfaced with transient stability itself, allowing us to use vendor-supplied DLLs within transient stability simulation and allowing for better grid code and system assessment in terms of dynamics and stability. Transient stability has been enhanced as well to include Inrush RMS plots that are meant for grid compliance. We saw these RMS plots when we looked at the plot views, where you can easily plot the instantaneous values as well as the Inrush peak. You can also see the Inrush value, the multiplier, and the time constant directly on the chart, allowing for deliverables to be more meaningful and more effective. The transformer editor within ETAP has also been modified so that you can essentially have an estimation of the Inrush curve directly in the program. Simply go to the magnetization page, and for transient stability you can use either a magnetization curve, which is point-based, that has current versus flux along with the remnant flux, or you can use equation-based approach. The parameter estimation allows you to simply put in a time when the inrush current is at or close to its peak value, assuming that the transformer is energized at 0 seconds. If the assumption is that the peak happens at 0.1 seconds after energization, and the peak current at that time is the largest measured value, which is 10 times FLA, then you can simply allow the program to recompute the inrush multiplier and the time constant and update it directly into the chart. This same information is then used by transient stability and can also be used by the star protection program. In order to use this with the star protection program, you can simply switch to the equation-based approach, and now transient stability and star TCCs would be using the same inrush curve that has been computed. ETAP transient stability has been enhanced to include transformer inrush plots for grid compliance and includes a new equation-based inrush current capability. So let's go ahead and see both of these two in action. We can simply go into our transient stability scenario and run this scenario for us to visualize what happens when we run the actual calculation. And we can see the actual inrush current pulsating as the magnetization of the transformer dies off, and we are essentially reaching a steady state value. But this value is essentially pulsating and makes it quite difficult to understand the starting point, the peak current, the inrush value, the inrush duration, and so on. And that's one of the key deliverables for grid code compliance. So therefore, one of the things that we've added in ETAP 20.6 is essentially an RMS envelope for the inrush current. So this helps us visualize a little bit more clearly how is the inrush actually decaying in the system and what is the peak value. However, you can go inside the plot view and pick the transformer that we are using in our simulation, select the inrush curve in RMS, which is new in ETAP 20.6, and click OK. And now you can see the actual envelope of the inrush, but you can also see the inrush value, the multiplier, as well as the time constant. So with this, you can deliver your grid code compliance study which may be related to a flicker in the system due to transformer magnetization, and not spend too much time trying to interpret these values from the actual Inrush response. ETAP 20.6 magnetization page also includes the ability to use a magnetization curve for the Inrush, which is based on percent current and percent flux, and you can also put in the remnant flux as well. But in 20.6, you can also use an equation-based approach where the peak current time can be plugged in by the user along with the peak FLA value, and you can also plug in the second time where the RMS current is considerably less compared to the peak value. And based on these parameters, the program can estimate what the Inrush curve would look like instead of you typing in these magnetization values in a manual manner. If we assume that the Inrush peak is 10 and the time at which the peak occurs is 0.1 seconds, we can see that our Inrush multiplier is 12 times, and this is our time constant. We can then go ahead and update our Inrush value, and then this equation-based calculation can be used by transient stability as well as ETAP star for protection and coordination. We can simply go ahead and run our Inrush simulation again and see the difference in results based on the new parameter estimation from the program. Since we were talking about transformer Inrush, let's look at transformer Inrush simulation and the TCC plot. Since the equation-based calculation is new in ETAP 20.6, you can simply go inside the transformer magnetization page. Again, make sure that the protection is using equation, piecewise, or point. If you're using equation-based, you can simply, again, evaluate the parameters, look at the multipliers and the time constant decays. Remember this value, 12.44, and we can essentially go into star and plot the transformer Inrush curve onto our TCC. If we go ahead and zoom in and look at the details of the Inrush, we can turn on our settings and see that it's actually using 12.44 with the time constant in cycles. So therefore, the parameter estimation that calculates the Inrush curve inside the transformer is available not only for transient stability, but also in ETAP star, now in ETAP 20.6. ETAP 20.6 also includes the sequence of operation available in the scenario wizard. So this allows you to perform multiple what-if fault analysis and put them into a batch along with the study wizard and really and truly automate the process of generating a comprehensive report. The protected device report also includes the ability to add comments, and you can also have device design assessment for circuit breakers and reclosures. Star now also includes DataBlocks. So you can use the DataBlocks which are on the one-line diagram for the star TCCs as well. Let's go ahead and see this in action. We can simply bring up a star view of our choice, zoom into the one-line diagram, and for this particular one-line diagram, you can turn on the DataBlocks. You can simply move the diagram outside the TCC and the DataBlocks move along with it. And the DataBlocks can also have the leaders or the active toggle lines. So you can really point out clearly this data block belongs to which component. You also have the ability to show the data block tooltip that you can simply turn on and off. The data blocks can be edited as usual by double-clicking and changing the parameters or properties of the data block directly from the data block editor. ETAP 20.6 includes improvements on the visualization, deliverables, and reporting for voltage stability. The plot view now has graphical plot results for voltage stability that includes VQ sensitivity, PV, and QV curves. Simply go to an ETAP project, run the QV analysis, the sensitivity analysis. Simply go to ETAP and run the sensitivity analysis, open up the plot view to essentially see the results of the sensitivity analysis across all the different buses. You can also run the PV and IV analysis across the entire system and see the QV and PV curves on the plot views at the same time. Data exchange has been enhanced to include a new exchange capability, which is Common Grid Model Exchange Standard. CGMES profile based on the IEC SIM standard is prescribed by the European TSO Development Organization, and it is a standard for the exchange of data necessary for regional or pan-European studies. By using CGMES SIM profile, you can import the equipment information and topology, automatically generate a single line diagram, and we currently support load flow and short circuit calculations as means of this import. So if you're exchanging data using CGMES from ENTSOE or any other tool that is capable of exporting this data, you can actually import this information into ETAP and once again rebuild the diagram without re-entering the information again. Data exchange, especially when it comes to SKM Power Tools 9.0 import, has also been improved significantly. We have improved the one-line diagram layout and the element mapping. We've also optimized the creation of multifunction relays and optimized it into a single relay. We can create nodes or buses based on connections and capture that intelligence as part of the import process. We allow more efficient library mapping for fuses, breakers, and relays by allowing a copy and paste function. We now support 3-winding transformers and also power factor and efficiency for multiple loading. The network modeling and project management is also enhanced that allows us to shorten the project delivery time through synchronization of composite network elements, synchronization of project settings, and an optimized web interface that has the change queues. So you do not need to see every single message in the system, and it's actually grouped and organized to give you the most appropriate picture of the changes that are passing through the NetPM queue. NetPM, as you know, allows you to collaborate in parallel from anywhere. So you can essentially use it to collaborate with engineers in remote locations, or you can use it to essentially speed up your power system study project by working in parallel. The ETAP app is also updated, supporting international character sets, improved split bus segment location, and intelligent device search based on property value and type, as well as an automatic backup of project and its recovery. You can of course get the ETAP app from the App Store or from the Microsoft Store, but very soon you will be able to actually grab it from the Android or Google Store as well. The engineering libraries have been expanded as well to include new circuit breakers and relay models, new protected devices, and of course updated cable libraries per new regulation types. The microgrid controller, which is a model-driven solution that allows user-friendly control and ETAP in the loop intelligence, is also enhanced and augmented based on its algorithms, as well as the feature set and the visualization of the microgrid controller functions. Operator training simulator that allows our customers to perform dynamic and steady state response with their electrical system in a trainer to trainee environment can now enjoy ad hoc and predefined scenarios along with improved visualization of the simulation results in a trending manner. Advanced fault location allows us to retrieve information in a CompTrade format and perform fault identification through various phasor and frequency estimations. The AFAS module has been enhanced in terms of its graphical visualization capability, and it now allows us to compare the as designed versus as operated sequence of operation in the same interface. The power plant controller, which is also a model-driven controller solution, now supports active, reactive, and energy storage management in a more optimized manner. It also supports ETAP in the loop situational intelligence. It is used to design and operate renewable energy farms for GridCode compliance. eProtect has also been enhanced that allows for centralized protection and asset management of the complete relay and substation infrastructure. You can seamlessly synchronize data between the physical relay and ETAP star. We now support automatic processing and relay setting file generation for many other relay vendors, as well as detailed exchange of settings for the existing adapters that we have as well. The project tracking and Gantt has also been enhanced. You can now show the today marker as an automatic marker in the system. You can use the settings editor to improve the look and feel, and you can also import the study macros and automatically create the tasks. So you can use this as a quick tool to keep track of your project progress, the delivery time frame, and keep it up to date with the studies that you're performing within ETAP. ETAP also includes a one-line diagram page break preview where you can easily set the page size, for example 8.5 by 11, and set up your diagram to print within this space. If you change the paper size, you can simply change the layout of the diagram to fit the larger paper size, making it easier to understand how your deliverables will be laid out before you print. The one-line diagram also includes annotation alignment, undo, and redo. So you can simply select the annotations that may be out of sync with each other, right-click on the annotation, align left, center, right, or adjust the spacing to get the correct layout that you would want for your annotations. You can then, of course, copy the annotation default and apply it to all the devices of the same type. We also now support auto-insertion of nodes for transfer switches. So as soon as you include a transfer switch, ETAP automatically generates the nodes without you having to create them yourself. We have also improved the circuit tracing. So you can simply start from a particular component, trace down, start from the load, trace up, or select 2 points to essentially go point to point between the network model. ETAP also now supports a property lock status per element. You can simply select the element, open the editor, lock or unlock the property, and ETAP will show you the lock symbol directly onto the one-line diagram. This will allow you to create a view or presentation of the network that shows all the lock capability. ETAP also now supports a background color fill for DataBlocks. So you can essentially go inside the Tools, Options, Preferences, and set the background data block color to your preference. We also now support color-coded elements with revision data. Let's see this particular capability in action. Revisions allow you to keep track of network changes within the same electrical model. Whenever we run a simulation within the program, we can see the results of our network model based on the engineering data that we have plugged in. If you want to make a change in the network model without making a copy of the database, you can simply pick from one of the existing revisions that are in the ETAP project file, or you can create a brand new revision. Let's go ahead and pick revision number 1, and we can go ahead and adjust the size of this particular load within our electrical model. Once the load size is adjusted, you can see that ETAP color codes this component as being different from the as-built or as-designed system or the base case. You can come back to the base case and rerun the computation and see the power flow in the network. You can then go to revision, have a clear indication of what is changed, and then of course rerun the calculation and see the difference in results. This capability essentially helps you quickly identify the components that have changed in that particular revision as a function of the data changes that you intend to do in the future. And finally, we've made the overall application more responsive throughout, and we have essentially improved, and we continue to improve the high resolution display support in ETAP 20.6. Please also take a note of the system components, including the third-party components that we utilize, which are the latest at this moment in time. In conclusion, ETAP 20.6 is an innovative expansion of the ETAP 20 series with advanced functionalities that accelerate electrical compliance and safety studies, improve digital power engineering and design, and reduce project delivery schedules through collaboration in your local language. That's correct. ETAP 20.6 is a multi-language edition, not just available in English. ETAP continues to invest tens of thousands of research and development hours per release, expanding on this advanced digital engineering design and operation solution with verified and validated engineering libraries. ETAP multi-language, multi-standard solutions help engineering teams design new power systems, sustain business continuity, improve productivity with team-wide global collaboration and information sharing while working remotely. We hope you have a chance to download ETAP 20.6 from the ETAP Help Center, and we look forward to seeing you in our next webinar. Thank you.